Hello, there we go. All right, I've just been given the go-ahead to start, so this seems like, okay. So I'm going to give a presentation that talks about the art and science, I suppose, of debugging software problems. What's really interesting about this is a lot of what we're going to talk about applies to software, but it also really applies to just kind of problem solving in general. I've been a developer for, I was trying to come up with a number earlier, and I was like, I always say 10 years. And then I'm like, it's probably been like 5 years since I started saying 10 years. But we're going to say I've been a developer for at least 10 years, mostly doing PHP development, but I've also dabbled in other things. My name is Joe. Joe Shindelar, or EOJ the Brave on Twitter, IRC, pretty much anything internet related that existed after about 1995. I currently work for a company named Lullabot. Lullabot is a Drupal development company. We do Drupal consulting, architecture, strategy, kind of anything Drupal related. We work with a huge variety of clients. And one of the things that I do at Lullabot, and kind of my primary role, is working on the education team. We have a website, drupalize.me, that's all about teaching people how to use Drupal. And the idea is that we work on all these really complicated Drupal websites for clients like MSNBC and Tesla and the Grammys. And we get a lot of experience building these projects. And we like to try to take that experience and contribute it back to the community. And we do that by producing the Drupalize Me website, which is a subscription-based service for learning Drupal, but charging that subscription also allows us to, in a sense, fund our time to write a lot of the documentation for how to solve things and how to do things in Drupal. And so we try really hard to make sure that, when we create these videos, we also take the time to contribute that knowledge back to the community. Anyways, that's a little bit about kind of what I do currently. I've been doing PHP development for quite a while. I was trying to think the other day, like, when I stand up there and I have to tell everybody how I got started with PHP, what am I going to say? And I think the answer is, the very first time I wrote PHP, I did it using Macromedia Dreamweaver. And so Dreamweaver used to have this feature where you could, Dreamweaver had this feature where you could connect it to a MySQL database, and then you could use the GUI to like drag and drop form widgets on the page. And then you're supposed to be able to hit a button, and it writes all the PHP for you to have like an interactive form that stores records in a database. The problem is, it never actually works. So if you want to learn how to write PHP, you create this form, and you hit the button, and it writes a bunch of PHP for you, and then you proceed to spend the next week or so looking at the source and trying to figure out what the heck is going on. That was my introduction to PHP. I've come a long way since then, but that's kind of where I got started. Over the years, I've spent a lot of time, as one does as a developer, figuring out how to solve problems in code that I've written or code that other people have written. And that's what this presentation is going to be about. They always say that when you start a presentation or when you start teaching something, the thing to do is like tell people what you're about to tell them. I find that it's also useful in conferences like this because if you don't want to stick around for the whole presentation, that's fine. There's other things to do, or if it's just not resonating with you, no problem. You have my permission to get up and leave at any time. But if you're going to leave, or if you're going to stay for the whole presentation, these are the things that I hope you come away from this presentation with a better understanding of. I'm going to talk about bugs in software or defects in applications that we create. I'm going to talk a little bit about where those bugs come from and how the fact that we're humans who create software makes bugs in our software inevitable. No matter what we do, we're always going to have bugs in our software. So if we want to be better developers, while we're taking the time to read the manual and learn how PHP works and learn about all the new fancy tools, we should also be taking the time to practice our debugging skills. If bugs are inevitable and we're going to write them, we should also work on how we're going to find them and fix them. For me, this comes down to coming up with a process that I can apply anytime I'm going bug hunting, anytime I need to find a defect. And that process really boils down to replicate the problem, isolate the problem, take the time to understand what it is that's failing, and finally fix it. And of course, do all of these things over and over and over and practice so that you get better at it. I like to talk a little bit about like where bugs come from, or kind of like why bugs exist in software first. Partially because I think that it helps to be better at locating those things and fixing them if you have some idea of like why they exist in the first place. And so in order to talk about where bugs come from, I think we need to define a couple of things. The first is we need to define what is software. So you'll have to forgive me because I realize I could probably spend like the next hour doing a presentation that defines what software is. But let's say at a really high level that software is essentially a set of instructions written by a developer given to a computer so that the computer can interpret those instructions and perform some defined task. You're writing a list of instructions to tell a computer how to perform a task. Generally, you're writing those instructions not in the computer's native language, zeros and ones or machine code. You're writing it in a language like PHP, for example. And so you're really writing a set of instructions that are handed to a translator, and the translator needs to translate those instructions into a language that the computer speaks, and then the computer needs to perform the task that you've asked it to. If you've ever tried to talk to someone in another language via a translator, you'll start to get an idea of how bugs exist in software, right? There's a lot of intent in the words that we use that is easily lost. Languages are very nuanced. Spoken languages like English, or even written languages, computer languages like PHP. And as really good developers, just like maybe a really good poet is capable of manipulating the English language in order to get you to hear or understand certain things or emotions. You know, when we're writing really creative solutions to a problem in code, we're also manipulating the language in a similar way. And we're hoping that the interpreter or the translator will be able to take the instructions that we've written and accurately translate that meaning into a different language for the computer. And it works most of the time. Turns out PHP is really good at this, but it also fails from time to time too. You think about it, like somebody writes a poem, and the poem is really great, and then 100 years later, somebody comes along and spends their entire PhD thesis trying to tell you what that poem means, right? So like language is very nuanced. And this is kind of where bugs come from in the software process. I believe that bugs are an artifact of mistranslation. Bugs are defects that arise when the instructions that we've written that we call software are incorrectly translated. It's when I write some line of PHP code and I think I'm telling the computer to do one thing, but it interprets it as something else. Another way to think about this would be if we've all written PHP. I mean, we're at a PHP conference. And so if you turn to the people on either side of you, both of those people and yourself have all at some time written code to solve the same problem, and you've all probably written that code in a different way to solve the same problem. So there's lots of potential for bugs to come up in software. I read a book about a year ago called Dreaming in Code. And in the book, this guy embeds himself into a company that's attempting to write basically like an email killer app. He stays there for 2 years, and he basically documents the human aspect of writing code. And that's kind of like, that book is what inspired me to sit down and think about more from the analytical and human side how we go about solving problems in code. And I like this quote from the book, and I think it really does a good job of making you like realize sort of the inevitability of bugs in software. So Scott says, there's a space between 0 and 1, between the way the machine counts in things and the way we count and think. When you search for explanations for software's bugs and delays and stubborn resistance to human desires, that space is where you'll find them. And it kind of alludes to this fact that when we as humans count, we start from the number 1 and we count upwards. But when computers count, they start from the number 0 and count upwards. But we're counting the same thing and we're counting the same number of them. And so our code is often filled with lines and lines of code that's sole purpose is to translate from 0 to 1 so that when the computer's counting, it can do what it needs to, but when it displays it for me, I see it in a way that makes sense to me. So that's kind of that's where bugs come from. Bugs aren't intentional. Well, okay, Maybe some people write bugs intentionally, but probably not. I like to think that all of us are writing the code to the best of our abilities, and we do so with the intent of describing the task that we want the computer to perform in a way that it can do so reliably. But inevitably, we're going to introduce bugs in the software we write. And I think that's important to remember, because when you're learning to be a developer, it's really easy to go, okay, so if I wrote a bug, what I actually need to focus on is getting better at writing code so that I don't write bugs. And that's true. There's a lot that you can do to practice not writing bugs, but there's also nothing you can do to completely be guaranteed that you'll never write a bug. This whole presentation is kind of me waxing philosophically about the various cognitive biases and tricks that our brains play on us when we're trying to locate problems in software, and sort of at a really theoretical level how we can go about solving the problems. And most of it holds true, but it's not necessarily rooted in fact. I think that there's one fact in this entire presentation that I can guarantee, and that's this. The only way to be a zero-bug programmer is to never write any code. Hands down, that's the only way. Even if all you do is write a single line of code, there's probably a bug in it at some point in the stack that it runs in. So being a better programmer also means being a better debugger. Debugging is the science then of tracking down these defects, those bugs that exist somewhere in that misinterpretation, and eliminating them from our code, rewriting the instructions for the computer in a way that it actually interprets them with the intent that we wanted it to. I think that there's kind of two aspects to debugging. There's the technical side of it, where you use tools like a debugger. Xdebug, for example, would be the one that you probably use with PHP. And you use those tools in order to inspect the bug, to observe it happening, to get some idea of how the system works and any application state or space in which those bugs occur. But there's also the analytical side of it. So there's the process of using a tool to look at the bug, but then there's also the process of figuring out where to look for the bug. And that's a bit more of the analytic side of it. In this presentation, I'm going to be talking more about the analytical side of things. Though, if you want to get good at debugging, you can't do one or the other. You absolutely need to learn how to use the tools. I used to always think that I could get I never took the time to install and understand how to use Xdebug. And I would spend hours just putting var dump statements in my code. And it works. And I could apply the same process, the analytical process, to find the bugs that we're going to talk about. But knowing how the tools work and using them makes that a lot easier. So I recommend that you take the time to learn about the tools that are available for whatever language it is that you're writing code in, and learn how to use them. Once you've got tools and you know how to use those tools, debugging really becomes a process of figuring out how to find where in the code or where in the instructions that you wrote the bug exists. And for me, that means applying a process rather than just jumping in blindly and starting to poke at things and figure out where the problem is. I like to take a bit more of the scientific method of when I go to search for a bug and try to eliminate that from the software, every single time I do it, I follow this basic process. I start out by trying to replicate the issue, basically make the system fail, because if I can't see the problem happening, I can't fix it. And then I try to isolate the problem. Isolating is all about, now that I can make it fail, I need to be able to describe sort of what causes it to fail, what class of inputs are causing the system to fail, in what space and time is it failing in. It's about narrowing down the search space so that in my debugger, I actually know what variable I should look at. And then I take the time to really, truly understand the problem. I say this, I take the time to understand the problem. For me, this is probably the one that I inadvertently kind of skip the most, but is also really important. But being able to, just because you can see the problem happening and then change some code and now it's not happening anymore doesn't necessarily mean you've fixed the root problem. You may just be hiding a symptom and not fixing the cause. So make sure you take the time to understand it before you fix it. So this is like any bug I try to solve, I try to go through this process. And I try to be really diligent about it. And I do all the steps. And I do them in this order. And I do all of them every time, almost. I actually generally start out by giving myself a couple of minutes to just dive in. And I call this like my 10 minutes of dirty debugging. Basically, I've worked with this piece of software for some amount of time. And that history that I have with the software gives me some ability to potentially intuit where the problem is. And so I'll just spend like 10 minutes, jump in, start making changes, and see if I can solve the problem very quickly. But I also have to be careful to sandbox, or time box, I guess, myself to 10 or 15 minutes or so. Because this like ready, fire, aim method is basically like the developer equivalent of jumping in and smashing your face against the keyboard and hoping that doing so solves the problem. And it might, and if it does, that's awesome because you spent 10 minutes and maybe you got a little bit of bruise, but no big deal. But after like 10 minutes of smashing your face on the keyboard, it starts to hurt, and you still haven't located the problem. And a couple of things happen. One, you're like, I've already invested 10 minutes in this. I must be really close. I'm sure the next time I do this, it's going to fix the problem. So you just keep doing it, right? And this causes frustration. And that frustration and anxiety about not being able to solve the problem works you up into a bit of a frenzied state. And when you're in that state, it suddenly becomes really hard to apply logical reasoning to a problem, to take the time to step back and actually like be methodical about it. This is like the #1 thing that I see people do when they're failing to debug a problem. You change a line of code, you hit refresh, it's broken. So you go back and you revert that change and you change another line and you hit refresh and it's still broken. And you just keep doing that and you start thinking to yourself, man, I've changed like half the lines in this file, I must be really close. The truth is, you're probably not anywhere close because you don't even know what you're looking for yet. So after you've spent 10 minutes hitting your head on the keyboard, if you still haven't solved the problem, stop. And take the time to step back and apply a bit of a process to it. For me, that process looks like this. The first step of the process is to replicate the problem. Generally, we discover that bugs exist because something happens. We get a support request from one of our clients, or somebody files a ticket in the repository for our software. Whatever the case may be, somebody's reporting to you that I attempted to perform this operation with your software. This is the result that I expected, and this is what I got. So in order for me to be able to solve that problem, I also need to be able to see the same thing that you're seeing. This presentation, when I first started putting the slides together a couple of months ago, I thought, man, being good at debugging is like being a detective. So I'm going to make slides that have like this sweet film noir theme, and it's going to be very poster-like, and it's going to have detective drawings. And I very quickly realized that there's actually a reason that I'm a developer and not a designer. The slides just basically looked like white text on a black background, and I was like, that's not as cool as it was in my head. So then I showed up here, and the whole theme at this conference was like, try to find the person that, the crime scene in a murder. And I'm like, oh, detectives again. This must mean something. So I decided last night to go through and intersperse some wisdom from the most famous detective of all, Mr. Sherlock Holmes, into this presentation about finding bugs. So Sherlock says that whenever he's trying to solve a problem, it is a capital mistake to theorize before one has data. Insensibly, one begins to twist facts to suit theories instead of theories to suit facts. So if you don't know what's going on, you don't know where the problem is, how are you ever going to fix the problem? So replicating the problem, a bunch of things that I do in this process of trying to replicate the problem. The first thing that I do anytime I dive into finding a defect in a piece of software is I start to keep a log. A lot of times you actually probably started to keep the log whenever somebody filed a bug report or when you got that support request. Is the initial entry into your diary that you're keeping about solving this case. The benefit of keeping a log is that sometimes these defects can take a long time to resolve. Some are really easy, right? You fix it in 10 minutes. And some of them take days or even months to get to the root cause and solve. And as developers, we have this tendency to dive into a problem and end up holding a lot of the problem space inside of our head. We've kind of looked at a lot of code and amassed a bunch of knowledge that we're holding inside of our head. And then you're getting close, maybe, to solving this problem. And then your coworker comes in and he's like, hey, I just left some chocolate chip cookies in the break room if you want one. And you're like, cookies? Yeah, I totally want one. So you go to the break room and you have a cookie and you come back and now you totally forgot what you were working on because you were distracted. And it takes half an hour or so to get that problem space all back into your head. So as you're attempting to debug something, keep a log. For me, I usually do this in the ticket that I'm working on for that particular bug. And it usually means at the replicate stage, what I'm doing is I'm trying to write down any notes that will make it possible for future me or anyone else that ends up coming to work on this to also be able to replicate the problem. The whole goal here is make the system fail. Your objective is to figure out a way to reliably repeat the problem and understand enough about what's going on that you can make the problem happen on demand. Sometimes this is super easy. Sometimes the problem is like, go to the contact page and hit the submit button. Look, the error happens. And that's great. So maybe you write up in your log, just follow these 3 steps. And if you do this, every single time you do it, the problem happens again. Sometimes it's a little harder, though. Sometimes you get these problems that maybe the defect only occurs 1 in every 100 or 1,000 or 1 in every 1,000 iterations through a loop. Or maybe it only occurs in certain states of the application that require a configuration. This is that whole thing. One of the ways you can get some idea of how good at debugging the person is that you're interacting with is when you file a support request, if they write back and they say, well, it works for me, must not be a problem. I'm like, oh, well, did you solve the problem? Works for me is not a solution. And people that write back and ask questions, it's working for me, I can't see it currently, but I'd like to replicate the problem. So could you tell me what browser you're using and what operating system? You're trying to gather any additional information you can in order to be able to replicate the problem. You can also do a lot of this too by laying traps, basically. If you have some theory about where the problem is occurring or what even causes the problem to occur, you can do a lot of things with logging. This is why a lot of applications contain a verbose mode or a debug mode. You set flags for the application and say, when this flag is set, dump all kinds of additional information about application state and configuration and environment into a file that I can go and look at later. So I work on a website that deals a lot with streaming video. And we had a support request come in recently where someone was unable to watch one of our videos, which isn't uncommon. This happens. And so we've got a set of steps that we always walk through to get people, could you flush your browser's cache and make sure that it's not just a bad JavaScript file for the player or so forth. So I went through these steps with our client, and he was still unable to watch the video. And so the next thing I had him do was to enable the logging feature. So we have some additional logging features inside of our video player. And I had him turn those on and send me the log records. Because I wasn't able to see the same problem that he was seeing. A lot of this, especially with something like a video player where there's a bunch of JavaScript that executes client side, it's really hard for me to replicate what's going on your computer. So I can't really simulate that problem. So I had him send me the logs, and I compared them to my own logs from performing the same thing. And it turns out what we discovered was that the problem, what was causing the problem was the Great Firewall of China. So we've got a customer who's in China, and he can't watch the video. And it's because one of the files from our CDN that contains a license key for the player isn't being delivered to him. And so videos don't work. There is no way, short of flying to China, that I could have ever replicated this problem on my local host. But because of logging built into our tools and my ability to ask the right questions, I had some idea of where to look. And then once I knew where to look, I could set a trap to try to catch that in action. Once I knew what the problem was, once I knew that the problem was he wasn't getting the file because of the firewall, I can stimulate the problem on my end. I like to use this mantra of stimulate, don't simulate when you're trying to replicate bugs. Your objective should be simulate the configuration that makes the system fail, but don't simulate the failure itself. You want to stimulate the system so that the failure occurs. One example would be if you're dealing with systems that are bugs that only occur when a system is under load, rather than writing some code in says, okay, cool, this is where it's failing. I'm just going to write some code in that says system is under load. And now I can test the problem. You might see the bug, but you also may have introduced another bug by adding additional code to the system to simulate the problem. Instead, you should stimulate it by using a load testing tool to put the system under load for however much time it takes for the bug to occur so you can see it in action. And then once you know how to replicate a problem, you should also automate that replication. There's been a lot of talk at this conference about writing tests, and this is a great point at which you could use one of those tools that you learned about for introducing testing to your system to say, I know there's a bug. I know I'm going to have to repeat this replication over and over and over in the process of solving it. Why don't I write some code that will do that for me? Finally, once you've been able to replicate it, make sure you take the time to add it to your log. For me, this again is tickets, and I do this for myself, and I also like to try to get everyone else on my team that I'm working with. Whenever you file a ticket, or whenever you start working on a ticket, add some steps to replicate the problem so that the next person can easily do so and doesn't have to waste half an hour figuring out what you already figured out. Once you've replicated the problem, the next objective is to narrow the space in which that problem could exist down to a point at which you've isolated it. You can say, I know for sure that the problem occurs in this function or in this method. So I refer to this as isolating the problem. And it's all about making the system fail reliably and then gathering as much data as possible about the various state and configuration and inputs that are causing the failure to happen. I want to be able to answer the question, what specifically is causing this problem to happen? So I can see it, now I want to know why it's happening. As Mr. Holmes would say, there is nothing more deceptive than an obvious fact. So you're like, oh, I can see that it's failing, but now I want to take the time to figure out why or where. I talked about this a little at the very beginning, just jump in and spend 10 minutes debugging things. This is often referred to as Easter egging, kind of changing one line at a time without really understanding what that change is doing and hoping that it'll fix. If you're trying to be logical about finding a problem, changing things at random and hoping it fixes it isn't going to get you any closer to isolating or solving the problem. So avoid doing that. If you ever have an internet, we all have the internet. If you've ever had issues with, say, your Comcast modem, and you call up Comcast support, the very first thing that they do is ask you, is your modem plugged in? And most of us are like, yes, my modem is plugged in. Yes. But there's a reason that they ask you that. And the reason is that there's no sense in spending a whole bunch of time trying to debug a problem when there's a really easy fix. We, as developers, have a tendency to believe that the problem exists somewhere in the code that we wrote. But that's not always the case. Our code is supported by a whole layer of other systems. There's the hardware layer, the computer that the code runs on. There's the operating system itself. There's the PHP interpreter. There's the code that we've written. I mean, there's tons of layers to this stack. So the first step should be making sure that all of the layers in that stack that make it possible for your code to run are operating as you would expect them to. Because if the web server isn't turned on, there's a reason people can't view the page. And it's not because PHP is failing or your code is wrong. It's because Apache isn't turned on. So make sure you check the plug. Once you do that, and you've confirmed that you've narrowed the search space down to, I know that this is somewhere in the code that I've written, now you can apply different techniques to just sort of methodically narrow that search space. A really common one is this idea of divide and conquer. If you've ever used tools like git bisect, this is exactly what git bisect does. It says, given a point in the past and the current point, I'm going to cut things in half methodically until I narrow down to where in the code this problem is happening. Maybe another example would be if you you've got a really long pipe. You've got a 100-mile long pipe. And that pipe is supposed to take clean water from one place and output clean water in the other place. And you're standing at the end where the clean water is supposed to come out, but instead you're getting pink water, so it's not clean. In order to find where that hole in the pipe that allowed the pink water in, you could traverse the entire 100 miles of this pipe and look at every spot to see if there's a hole. Or you could jump all the way to the beginning and confirm that the water going in is actually clean. And if it is, well, that's okay. You know for sure the problem is in this 100 miles of pipe. Now you could go to the 50-mile marker, and you could open up the pipe and determine whether or not the water is clean or pink at that point. If it's clean at that point, you can safely make the assumption that the problem is somewhere between the 50 and 100-mile mark. So now you can jump to 75 miles. And at 75 miles, you can do the same thing. And you can keep splitting it in half like that. So you've got something that's 100 miles long. That would mean that rather than checking every 100 miles, you could do this within 7 moves. You'd be able to find for sure which mile that bug exists in. So taking the time to divide and conquer is, again, it's just applying a methodical process to isolating the problem. When you're doing that too, when you're trying to isolate problems and you're changing things in the code and looking for where the problem exists, make sure that you're only changing one thing at a time. I do this a lot. It's really easy to go in and make a change to try to see if that's affecting the application at all or not. And then, nope, it's not. OK, so I make another change. Nope, that's not, and I make another change. If you don't remember to back out the other changes that you've made or unchange the things, you have no way of knowing whether you found the bug or you actually introduced a new bug, and you're looking at a new bug that's related to a change that you had made while trying to find the original bug. Yeah, no fun. And then all of this kind of boils down to when you're trying to isolate a problem, stop thinking about the problem, stop thinking you know where to find it, and take the time to actually find it. Look for the problem. I used to own a house that was built in 1908, so older house. And as you typically do as an owner of an old house, you spend a lot of your evenings and weekends trying to debug problems in your house. Like, why won't this door close? Or why won't this window open? Or how come these steps are squeaky? So I woke up one morning and I go into my bathroom to brush my teeth, and there's a pool of water on the floor. And I'm like, oh, something must be broken here. After a little bit of debugging, I determined that the problem is the toilet, and I can replicate the problem by flushing it. And like 1 out of 10 times or so, when I flush the toilet, water spills out underneath, and I've got a mess on the floor. And so I hop on Google, and I start, because I know nothing about plumbing, I hop on the internet, and YouTube tells me, oh, this is probably a wax seal. All you need to do is take the toilet apart and put in a new wax seal and put it all back together and everything will be fine. And I'm like, sweet, I think that's the problem I'm having too. So I go and I replace the wax seal and put everything back together, and sure enough, it's working fine for a while. And then it starts failing again like a week later. I wake up and there's a pool of water on the floor again. The problem is that I thought I knew what the problem was, but I hadn't taken the time to stop thinking about the problem and actually look at the wax seal and see if it was broken. So the second time around, I took the time to, well, first I called the plumber. And the plumber told me, put some dish soap around the bottom of the the toilet, around the base of the toilet and on the porcelain a little bit, and then flush it a bunch and see if you can get it to leak again. And I did. And it turned out there was actually a crack in the base of the porcelain of the toilet. So it had nothing to do with the wax seal. But I wouldn't have ever known this because I was just like, well, I don't know, the internet says it's a wax seal. So I replaced the wax seal. Once I could see the problem happening, it was really easy to fix it. I could just use some porcelain patching compound and fix it. And I could put dish soap on there again, and I could confirm that it was actually fixed. I didn't have well, I assume the problem hasn't happened again. I actually sold the house a few years ago, so maybe it did, but I don't know. But stop thinking that you can solve the problem and look for the problem. Potentially save yourself some time and money too, and when you do so. Don't solve the wrong things. When you're isolating the problem, the goal, or what you should be trying to enter into your log for this problem, is an explanation of what's causing the problem to occur, including as many details as you can about the application state or specific configuration, hopefully narrowing it down to, this particular function is where the problem's occurring. I input this, and I expect to get X out, but instead I'm getting Y. As much detail as you can. Once you've been able to isolate the problem, at this point, it's actually really easy to start going, oh, I've isolated the problem. It's somewhere in this function. I should just go ahead and fix it. And again, this is the step for me that I tend to skip a lot. But I think it's important to be able to understand why the system is failing. Not just fix it so that it's no longer failing, but really understand what's going on and what's wrong. And this is actually one of the trickiest parts for me too, a lot of times. It's as a developer, I want to very quick, I get a bug report, and my objective is basically, I want to close that bug report before the end of the day. It makes me feel good when I check this thing off my list. And so sometimes taking the time to really just slow down and understand, even though I've already know how to fix the problem, is a frustrating experience. And there's a few reasons for this, and things that make it hard to understand some of these problems. One of the things that makes debugging really hard is being human. Our brains have all of these different tricks that they play on us. And actually, they play these tricks on us, and they make us really efficient developers, but really bad debuggers. I was doing a bunch of research about this and sort of what makes it hard for someone to apply logical reasoning to a problem. And so there's all these different cognitive biases that our brain has. A couple of them are one of them is the idea of confirmation bias. And so confirmation bias is this tendency that we have as humans to try to understand the world around us by starting with a conclusion and then basically polishing that conclusion by having biased observations of everything that happens in the world. It's the reason that most of your friends on Facebook agree with the same things that you agree with. They have the same political outlook as you. You surround yourself with things that confirm your existing ideals. The same is true when we're working on solving problems in software too, right? If I jump into a bug thinking, oh, I know exactly what's going on here, it's really easy to start looking at the code and have all of the code look like it's confirming what I already think I know. But that's not always necessarily the case. Another one of these weird tricks is what's called the availability heuristic. The availability heuristic is, it's this mental shortcut that our brains use in order to more rapidly solve problems. Let's see, what would an example of this be? Our brains inherently trust our memories more than they trust facts. Things that you can easily recall, you're more likely to recall and believe. So if something has recently happened to you, if you recently solved another bug in the software that looks like or is similar to this one, your brain starts to go, oh, this is probably the same thing that happened before, even though it may not be the same thing. It's these mental shortcuts. What's kind of wild about these mental shortcuts is I would argue that they make it hard to debug, but they also make me a really good developer because I can do things like use functions in PHP without having to look up the documentation every time, because I remember how the function works, and I assume that it still works the same as last time. And so that makes me a more efficient developer, but it makes it hard to debug. So the thing about trying to understand what is causing the problem or what's going on is that you need to be careful not to make any assumptions. So an assumption is anything that you believe to be true or certain to happen without having without any proof that that's true. So an example of assumption might be, I could say just because the sun has risen every day since the beginning of the earth doesn't mean the sun is going to rise again tomorrow. I assume it is, and it probably will, but I have no way to prove that the sun's going to come up tomorrow. So I just have to make an assumption that it is. As a developer that's dealing with debugging, you should get into the habit of asking yourself, when I'm trying to understand this problem, what assumptions am I making about the system? And then you should document those assumptions too. You should write those down in your log, because a lot of times the problem, or the reason that you can't find the problem, is you're skipping right over it because you assume something worked. So the classic PHP case would be you're using one of the various string functions that take all of their arguments in random order, and you assume that someone's passing in the arguments in the correct order. And you assume that you remember what the correct order is too. But if you don't take the time to read the manual and make sure that you know that that's the correct order, and to look at that and make sure they're passing in the needle in the haystack in the appropriate order, you don't know for sure that that's not where the problem is. Which generally means reading the manual. I can't emphasize this enough. When it comes to trying to understand why something is broken, read the manual. And if you've read it before and it's been a while, read it again. Don't assume that you understand how someone's API works. They might have changed it and hopefully updated their manual. I make no promises about that. But all of these things that's like, well, last time I used it, it worked this way. Or I've done this before and this is how I did it. Read the manual and make sure you're doing it the right way. I like this. There's this. I have no idea if this actually happened or not, but the story goes that someone in a conversation with Albert Einstein asked him what his phone number was, and he was unable to recall his phone number. And when the interviewer then asked him, like, what do you mean? How could you not remember your phone number? He goes, why would I bother taking the time to remember my phone number when I can just look it up in the phone book? So as a developer, we do this a lot. Why would I take the time to memorize how a certain function works when I can just go look up the documentation for that function? But when you're debugging, make sure you go and look up the documentation and that you're correct. And finally, a really great tip for if you don't understand how something works, ask for help. Maybe somebody else that you're working with has encountered this before and knows the system, and they can help you solve the problem. Sometimes you can even talk to people that don't even know anything about the system that you're trying to solve, and just the act of trying to explain to them what the problem is will help you better understand it. One of my coworkers, and I think a lot of people do this, but one of my coworkers has this yellow rubber duck that sits on his desk, and it's named Klaus. And I swear, Klaus is the best debugger in our entire company. He doesn't write any code. He doesn't even speak. He's a rubber duck. But he's able to solve almost anybody's problem. Because if you're having a problem and you can't figure out what the solution is, you call up Brock. And you say, Brock, I'm going to try to explain this problem to you, and maybe you can help me understand it. And Brock's like, sorry, I'm too busy. I don't have time to talk to you, but you can talk to my rubber duck. So he puts the rubber duck in front of his webcam. And so then you sit there for like 10 minutes explaining like, okay, so I've got this code that executes, and it's supposed to save a record to the database. But for some reason, and it does, but 1 in every 100 times it doesn't, and things are out of kilter. And you're like, so I assume that what's actually happening here? By taking the time to explain out loud to someone what's going on, a lot of times we're able to very quickly point out for ourselves what's going on, or they can ask us questions that we maybe weren't thinking before. So It's also a really safe thing too, right? Like we've already said that bugs are an inevitable part of the software development process. You don't need to be embarrassed by the fact that you wrote code that has bugs in it. Every single developer does it every day. So we should be comfortable talking to other people about those and feel that it's okay to ask for help. Same thing, when somebody asks you for help because they have a problem that they're stuck on, take the time to help them understand it and not just blow them off as like, oh, it's your bug, you need to fix it. Remember that someday you might need to ask them for help as well. So the goal of this step, understanding, is to be able to explain the root cause of what's going on. I want you to be able to point to what line in the code is broken, why it's broken, and explain to me how you're going to fix that problem and why the fix is the right solution. Mostly in the ticket, this for me, in that log appears as when I finally submit the code that fixes the problem, I also like to write, I usually write quite a bit, a couple of paragraphs, but whatever it takes to basically explain. I went through the process to find it, and here's what I found. Here's any assumptions that I'm making, and here's why my fix is the appropriate fix for this problem. So once you have replicated the problem, isolated it, you understand what's going on. At this point, fixing it is generally relatively easy. Like if you understand it, where it's failing and why it's failing, you just need to correct that failure. Generally, at this point, you're not doing a lot of analysis. Now it gets a bit more technical. You just go in and adjust the code, and it may take a while. You may have to refactor an entire system or whatever the case is. But fixing it should be a matter of taking everything that you've learned so far and applying that. So Sherlock says, once you've eliminated all the other factors, the one which remains must be the truth. So yay, fixing, you get to have a party. A couple of tips about fixing a problem though. One, don't stop fixing the problem until you're done fixing the problem. This happens a lot. People will like kind of come along, isolate the problem, replicate it, isolate it, write some code to fix it, and then call it done. But it's not actually done if you can't also prove to me that if you now go through all of those steps again, the problem doesn't occur, right? So I figured out how to replicate the problem in the initial pass, and maybe I wrote a test for it too. So after I fixed it, if I haven't confirmed that my tests are passing, I don't even know if I've actually fixed it or not. I'm just assuming that I've fixed the problem. So once you've applied a fix, take the time to verify that your fix works. And I would also recommend for a lot of things to take the time to remove your fix and verify that it's broken again once your fix has been removed, and then apply it again and make sure it's fixed. Make sure you're fixing the right things. Again, establish causality. Take the time to understand what caused the problem to happen and why your fix is the right solution for it. If you don't do this, you don't actually know if you're fixing the right thing or something else. And that's important, because this happens a lot. You start to debug a problem, and ultimately you end up finding other defects in the software as well. But you want to make sure that you're solving the original defect and opening new bug reports to come back later and solve the others. And again, write tests for your fix. Once you've taken all of this time to go through all of these steps, you never want to have to do it again, right? So write a test to make sure that your steps for replicating the problem are automated and that the problem is fixed, that when you perform those steps, that the problem doesn't occur. The goal of this step is to close the ticket. This is the most fun one. You get to hit the green close button and add a GIF of yourself being like, yeah, I fixed the problem. So in your log, you would basically want to go in and mark this as problem solved. Here's the solution that was applied to solve this problem. Make sure, though, that you do that. Make sure you take the time to close the ticket and to document how you solved the problem in case somebody else encounters that problem again. Or in case yourself encounters that problem again. I can't tell you the number of times that I've found a problem in a piece of software. Most of my experiences with Drupal, and so I'll find a bug in Drupal and I'll write a patch or I'll write a bug report and I'll submit it back to the project. And 5 years down the road, I'll encounter a problem and I'll be like, man, what is going on? And I'll start searching through all the documentation and through the issue queue, and I'll find, oh, this is great, someone solved this problem. Then I'll be like, holy shit, I solved this problem like 4 years ago. Thank you, past self, for writing down how you solved the problem. So take the time to do that. So recap, the process here is replicate the problem, make the system fail, isolate the problem so that you know what's causing it to fail, understand why that class of inputs causes the system to fail, and finally fix it. And when you fix it, make sure that you don't stop until you've actually proven that you fixed the problem. I kind of talked about this a little bit at the beginning, but this is one of those things that to get better at requires a lot of practice. And practice means coming up with a method that works for you. This is what works for me, the isolate, or replicate, isolate, understand, fix. In order to practice something, you have to have a plan for how you're going to do it, and then you need to execute that plan every single time that you do it. If you debug problems differently every time you attempt to debug the problem, you're not really you're getting incrementally better, but you're not improving the system that you use to fix those problems. So I like this quote, and I was super excited to be like, man, I can quote hip hop in a presentation about debugging. This is great. So the quote is, the greats weren't great because at birth they could paint. The greats were great because they paint a lot. And the idea is that you're not born good at debugging software. In fact, we're born bad at it. We have all of these cognitive biases and tricks that our brains play on us that make it harder to do. So we need to spend the time developing those skills and getting better at it. That's what I got. That's how I go about debugging software. We've got like 10 minutes or so left, and I'm happy to answer questions if people have questions or whatever the case may be. Thanks. Yeah? Why do I call it a dark art? So the question is, why is this titled The Dark Art of Debugging? Mostly because I was trying to come up with a catchy name for the session so that when I submitted it, people would be like, oh, that sounds cool. I'm not kidding. The idea for the session was being able to talk about sort of the non-technical skills in debugging. And so I wanted to, I guess that's kind of alluding to the fact that like there's a lot of things that we do when we're debugging that aren't dark art. It's not magic. We're not making this stuff up. But it's easy to, when you're learning to be a programmer and you're learning to debug, it's easy to look at someone who's solving a problem and say, oh, they solved that problem with Xdebug. And it's like, well, yeah, they kind of solved the problem with Xdebug. That's one of the tools that they use. But there's also a lot of other things that they were doing in their squishy gray matter inside of their skull that allowed them to solve that problem. So, does that kind of answer the question? Mostly because it sounded awesome. Any other questions? Yeah.
Any like real world like anecdotes of using the setting a trap?
Sure. Let's see. This is the like recall problem. Yes, I'm sure I do. I'm struggling to come up with any. I mean, the practical, or like what you would be trying to do is, let's say you're running a site that's got a very high user load, and you've got multiple webheads for that site, and you've got some scenario in which like maybe one of those webheads fails on 1 out of every 10,000 requests, and you need to figure out why. And you can't replicate that because you don't have 10 webheads in your house, and you don't have 10 million users hitting the network in your house. Maybe you do. But so in order to catch that problem in action, you need to be able to put some additional tooling into your application or into the stack that's basically listening for it to happen and then logging when it does. You tend to not run PHP and Apache and all of those things in their full verbose debugging mode all of the time, because it's just overkill. And so, especially for something like that where there's a lot of requests going on, what we might do is architect the system so that when the problem occurs, you've basically got extra code in there that's listening for that exception and saying, when this exception happens, write as much information as we can to the log. And then it becomes this issue of like, okay, cool, you let it run for a while until you finally have something in the trap that you can look at. And then you go and you take a look at the logs and see if the information that you need to figure out what's going on is there. It took us a while to figure out that the reason that this gentleman in China was unable to watch videos was because one particular file wasn't loading for him. We had to add some logging, and the first thing we discovered was, well, this logging isn't telling us anything useful. We think what might be going on, based on the fact that the error that he's seeing says this, and if I read the source code, it looks like what would trigger this error is this other thing. So I'm going to add some additional debugging to see if this other thing is ever actually happening. You're kind of like developing a hypothesis about what might be going wrong in the software, and then trying to prove that hypothesis. And then, it's the whole like scientific method where you start really broad and narrow it down the more and more you know about the problem. But again, it's that like, when your software never runs in a controlled environment. It's running on somebody's computer or on their phone or on their watch or whatever the case may be. And they've got all kinds of other applications that are running on that machine. And so simulating the environment in which your application is failing is really hard to do unless you can just go sit next to the person and use their computer to see it failing. And so laying a trap is all about trying to catch the problem in action on the system where the failure is taking place, rather than trying to simulate the failure on your own system. Because if you don't know if you're actually solving the right problem or you've just discovered a new one. Yeah? Yeah, you bet. Any other questions? Awesome. Well, thank you guys for coming. Please take the time to rate the talks. This information is super helpful to myself to help improve it in the future, and to the conference to make sure that they're getting the right talks and so forth. And that's all I got. Thank you.